We're waterproof system specialists. We've been in the business of putting roofs onto industrial buildings for about 40 years now. And in the last 15 to 18 years, we've begun to focus quite keenly on the data center industry. And our offering is changing as the industry changes. So I shall bring you along here. So that's us, MOY, we're waterproofing guys. And this is our pathway, this is our 5-point plan, which is guidance on how we sit down with a person who's developing a building, and we give them the guidance on how to develop the specification or the recipe, the listing of the elements that are going to be put into that particular roof assembly. And we do it so that we can hit point number 2, which is a cost optimal delivery of the roof system. And I know the speakers, 2 presentations earlier were talking about life cycle cost analysis, and for us, cost optimal spec delivery is key. We've got to deliver a roof system that's obviously going to keep water out, but during construction there might be ways in which we can get short-term temporary waterproofing into the mix, which can shave weeks off the construction program. So that's what we're talking about when we say cost optimal spec delivery. The building phase management then is our overwatch, our oversight, which in different marketplaces we have different legislative forces. In Ireland we've got the regulatory requirement to oversee the construction, but in other countries throughout Europe that regulatory requirement's not there. But it's part of our service offering, the build phase management, to make sure that the roof goes in as it should do. At the end of the construction period, we verify that the job's been done properly, usually through thermography as well as inspection. And then point 5, which is quite important for us, is we deliver to the end user, to the occupier owner of the building, the toolkit necessary to maintain the roof, to keep the roof in good condition. So one of the key things that we bring to a person who is trying to locate in Ireland or in Europe or wider afield is the ability for us to interpolate the design requirement that would come from a plan of record, perhaps in the United States, and to see how that fits in with the legislative framework that's present in the country within Europe, because quite a lot of the different territories will have little nuances that will preclude you from doing something in France that you might be permitted to do in the UK, or something in Ireland that you're not permitted to do in Austria. So we have a specialist team that can deliver and navigate those regulatory and framework changes from country to country. Big part of the assessment of the roof systems is going to be testing them to destruction, testing them for wind uplift resistance, and most importantly, testing for fire resistance. So we test our systems both to international voluntary code like the FM Global compliance framework, and then we'll also have our systems tested so that they meet with the local national framework. So it's not good enough to have just a global FM approval. You also have to make sure that you comply with the regulations of the territory that you're about to build in. So that's a big part of what we do at MOY. One of the key things that we're aware of is that, like everything else in construction, evolution is a continuous and ongoing process. And in the design evolution that we're seeing that relates to flat roofs over buildings like this, we're seeing huge reductions in the emissions, the carbon-based emissions, and we're trying to cut those down by producing roofs that have a high degree of solar reflectivity. We try to reduce the consumption of carbon fuel consumed within the building for heating and for cooling by keeping the roof cool. We're also looking at design evolutions, which we'll talk about later in this little presentation, which is the embedded technology that we can embed into the roof, which gives you a warning in real time if your roof is underperforming in terms of waterproofing or dealing with humidity or moisture. So more on that now in a moment. One of the key things that we're all focusing on when we're building buildings today are the reductions in greenhouse gases. How do we cut down on the carbon-based fuel emissions? So our Scope 1 and our Scope 2 emissions, those direct and indirect emissions, can be heavily influenced by the building fabric. And because of the typology of the buildings that we see, particularly in the data center industry, they tend to be large surface area roofs, usually single story in the Irish context. Sometimes they're multiple story in European, particularly in city locations. But because the roof represents such a large portion of the surface area, it represents a big part of the building fabric that we can harness to cut down on the Scope 1 and the Scope 2 emissions. So we do that by cutting down on radiated heat energy. We look very carefully at the thermal isolation layer that we're going to use, and the living roofs that you're seeing in this picture. The addition of the living roofs, which is what Gary was talking about, is really beginning to catch on within the data center industry. Quite a few of the DCs being constructed in Ireland today, for instance, are featuring living roofs, some not far from us as we stand. The Scope 3 emission reductions involve us looking at how we can, as suppliers of a roof system, help to make sure that the building, that it's during its operational phase, that it's producing as little carbon as possible, or burning as little carbon as possible. So we'll use products which are inherently low carbon. So they'll have environmental product declarations, EPD certificates, which was a deep dive into the amount of carbon that's embedded in the physical fabric of whatever you choose to build your building from. And we optimize the roof assemblies then to minimize those carbon emissions. And we have found that our customer base, our consumer base, they respond very, very positively to those efforts, and that their customers in turn respond very positively to them for building buildings which are proven to have a very low carbon footprint. So it's a win-win for us and also for our customer. One of the newer technological areas that we're looking at, and as very much as part of the development and evolution of roofs, is the entraining of monitoring systems into the roof. So there were lots of different approaches made in the past using electronic sensors which detect moisture in build-ups. What we've managed to do is we've managed to harness the physical fabric, the physical materials that we use to build the roof. We can take the electrical impulses from those materials, and we can read those electrical impulses to tell us if we've got humidity issues, moisture ingress issues in real time, and to give us a real alert in real time. So it's called intelligent roofing or smart monitoring technology. There's a number of different formulations that we can use to build this into a roof construction. And if you choose to put it into your building, it's relatively low cost in the context of the building fabric. And what it can do is give you an analytical dashboard that tells you in real time what's happening with your roof, what your humidity levels are, what your moisture levels are. And that data is securely stored within the territory of Ireland, or it can be securely stored on the campus where the DC is physically built. So we can work with the client to make sure that the data doesn't go outside of a field that they're comfortable with. Some clients want to monitor their buildings globally at one central hub or location, and we can set it up to do that. Other clients will never want the data to leave the physical campus, and again we can do it that way also. So it's quite an interesting technology, and if anyone wants to talk to us about it, we're available. The last thing that we want to talk about in terms of the evolution of flat roofs is the replacement of lost habitat. As Gary said earlier, the World Health Organization tells us that the wild bees, those mining bees, they're the heavy-duty lifters of the pollinator world, and they're responsible for 7 in every 10 mouthfuls of food that you will consume. And if we can replace habitat that gives these little creatures somewhere to live, then we're delivering ecologically for the area that we're building our DCs or our large buildings into. So at MOY, we have developed roof systems which use soils which are configured to allow those mining bees to be able to burrow and to live within those rooftops. And the planting scheme then is a native planting scheme which will be native to the area and configured to grow well in that particular area. So the replacement of lost habitat then, that's our other key innovation in terms of development of flat roofing. So that brings us to the end. So thanks very much for your attention. Hope I didn't bore you too much on flat roofing. And if you have any questions, I'm open to questions and answers. Okay, thank you very much.